Okay, hello everybody. Can you all hear me okay, yeah? Yeah, cool. All right, so that pretty much covered who I am. I'm a software developer. I've been doing this for about 6 years now. At the moment, I'm doing a lot of work in JavaScript, and so I thought I'd share, I think, what is a really interesting little JavaScript library. I'm avoiding the term framework. It's a really interesting small JavaScript library, and I think it has some concepts about it that are going to stand the test of time. I'm not a developer of this framework. I'm just somebody who uses it and is really, really interested in seeing it being used on a wider scale. So Redux, I read the documentation for it. It introduces itself as a predictable state container for JavaScript applications. And that kind of massively confused me because I didn't really understand what problem it was trying to solve. Took a step back and just through study, I realized that the problem it's trying to solve is that basically it wants to make mutations to your application state predictable. Now, the reason that's a problem is because sending, web applications are no longer just sending a bit of HTML to a client and rendering it, and that's it. It's not like my old GeoCities website anymore. We've actually got millions of different concerns that we have to deal with. We've got the pesky user who's clicking buttons and typing and all this kind of stuff. We may have some logging that we need to perform back to a server. We may be reading some kind of data if we've saved some user settings. We'd be communicating with an API to tell the server that something's changed. And of course, in the applications I'm working in, we've also got a live stream, perhaps news, stock info, something like that. So you've got changes to your application coming in from multiple different avenues. So it's basically recognizing that web applications are becoming increasingly feature-rich. That makes them complex, and we need to find a way to manage that complexity. Now, as the web started to grow and we started using JavaScript, a lot of the libraries that came out adopted the model view controller patterns, model view presenter, model view, view model, whatever, that are very common on the server side. But because we have all of these concerns, what happens? I've nicked this slide from Facebook. I'll show you why in a moment. But what happens is that you get an absolute plethora of change updates with these frameworks, normally because there's some kind of two-way binding mechanism that exists between your model layer and the view, so that if the user types something, it gets updated in your model automatically. And if something like a live stream changes the model, the view gets updated automatically. What happens then is, something will change. It will fire off millions of events which will change the state in one place that causes the state to be changed somewhere else. And you get a big web. It's very difficult in these kind of non-deterministic systems to debug what has actually happened. A few years ago, I wrote a two-way binding framework for WinForms and lost a good couple of weeks because of this kind of change propagation bug. So I had basically 3 input forms that were all related to each other. So you change one and it would perhaps change a value in another, and that would then cause the other input box to change in an unpredictable way. So you would have one case where we'd fix a bug and the tester would find another, and you would fix that and you would recreate the old bug again, just because tracking all these states throughout your application was pretty much impossible. And Facebook had this problem too. So Facebook had a bug where you'd get a notification and you'd click to see what the notification was, and then the notification would go away because you've read it. You'd then browse to another page on the site and hear the notification's back. And it was because this state was somehow getting lost in their system. And so what they did was they said, actually, we don't need to do this really complicated two-way interaction anymore. Let's just keep it simple. So they introduced the concept of a unidirectional architecture. And all it means, it's nothing complicated. All it means is that there is one route into your system to make any kind of change. It doesn't matter what that change is, whether it's a UI event or whether it's a response from an API call or whether it's a WebSocket connection. It doesn't matter. It goes in through one central route. When that change comes in, we update our application state accordingly. Maybe if it's a UI event, then we will, if it's like clicking a button, for example, we may call something to make another network request or whatever. Once we've done the update, once we've kind of settled our application state into a state that we're happy with, then we redraw. And certain UI frameworks like React are really, really good and really fast in this kind of scenario. But what it means is that actually the path through your system, there's one of them, that's why it's unidirectional, but it's also very simple and it's very predictable in nature. Facebook popularized this with what they call the flux pattern, and they provided some of the tools to do this. And Redux came about as it takes this pattern and it reinterprets it. So we're still sticking to this, but it also applies some constraints on you. They call them principles. It basically says if you want to build an application the Redux way, have your application state live as a single object tree, and we're going to put it in one place, a single source of truth. So if you need to get that state, there's one place you need to look for it. That state, by the way, you can only read it. There's no setters. But if you want to change it, you have to go through its common central update mechanism to do that. And it also says the way you update that is made with pure functions, and I'll come back to what that means if you're not aware. So this sounds really interesting, and when I first read it, I was like, I wish I had this a few years back because this would have solved my problem. But let's build it up one by one, and we'll see how this kind of evolves. So a single source of truth for your application state as an object tree. Now, the Redux library, it's quite a small library. It's 2 kilobytes when it's minified in gzip, so it's quite small. It has a method on it called createStore. You pass some params. We'll come back to those in a moment. But what that basically does is it gives you this object which is designed to hold onto your application state. And your application state will look something like that. It's just a big JavaScript object, a single JavaScript object. You can break it down into sub-objects if you need to. How you structure that is entirely up to you. And that state is read-only. So there's a method on your store that's created for you called getState, which lets you get at that object and perhaps do something with it. But if you want to change it, it's just a JavaScript object. There's no set methods. The store also provides a method called dispatch. And this is how you tell the store that there's been a change and I want you to update accordingly. It takes what's called an action. And an action, hey-ho, it's just another JavaScript object. You know, you construct these yourself. There's no format that you have to abide to. You can use whatever format you think is best for your application. But obviously, standards and patterns have emerged from this. One common pattern is to have a type property on your object with a string to describe what the action is. So in this case, for example, it's to set a title. And because it's just an object, if you need to pass any other data with the action, well, you can just add more properties. So here, for example, I have an ID of an article I want to update, and I'm changing the title. It's very common, just because these are plain JavaScript objects, it's very common to have an action creator. That is a function which just returns that object. So there's one place in your code which is responsible for creating that action, making sure it's well formatted. It also means you can do some nice things like pass in arguments to it and not really concern yourself with how it's formatted. So the action creator function returns your action, and you call dispatch on the store with that to say something's changed. And that's the only way you can change the state in a Redux application. So next it says that, okay, you dispatch an action, you've got to update the state somehow, and updates are made with pure functions. Now your store, it's created by Redux, it's just a factory object. It doesn't know how to change your application state in response to an action because it's your application that you're writing. You know how to do that. All it says is, give me a function to call whenever I dispatch an action. And what it basically does, it calls this function and it gives it 2 parameters. It gives it the current state object, and it gives it your action that you've passed. And it expects you to return a new state object in response. So if you look at that function signature, people who are up to date with functional programming or maybe familiar with the JavaScript API will realize that this is a very similar function definition to what a reduce function is called. So that's what Redux says. This update function is a reducer. Its job is to take your old state and this change event, and combine it into a new state object. So we call these reducer functions. And it's very important that this reducer function is pure in nature. And all that means is that the output of the function depends on the input argument alone. It's not going to do any other side effects. So, for example, if we have an array with some numbers in it, and we call a function called square, we expect the result of that function to be returned. So 4, 9, 16. We don't expect it to modify what we passed in any way. So if I call that again, I would expect to get 4, 9, 16 because it hasn't changed that original array value. If it gives me 16, 81, 256, it's not pure because it's modified that original input. Likewise, it can't do anything like math.random, which is impure, because when we call it, who knows what we're going to get back? It can't make any network requests because we're not going to get an answer back immediately. They're dependent on time, and there's a bit of unpredictability there. So it means that these update functions, they can't actually do a huge amount of interesting things. They're just really dumb. They're just going to update your state in response to an action coming in. And that's what makes it predictable. Now, I don't have a huge amount of code to show you today, so forgive me for this slide. But this is an example of what a reducer looks like. It's a very basic one. Let's just go through it line by line. So we have an initial state. Here, I've just got an object with a name property on it set to null. Again, whether you have an initial state or what you set it to is depending on what problem you're trying to solve. And we have our reducer function. I've called it update here. It takes the two parameters. It takes state and it takes an action. Now, if the state isn't supplied, we're going to assume a default initial state. So my action from earlier on, it had a type property on it, which tells you what type of action, what type of change is happening to your system. So I'm just going to do something really, really simple here and do a switch statement over them. So when the setName action comes in, what I'm going to do is create a new object, which has all the previous values on the state, but I'm going to update the name one to our new property that's passed in. Now I'm using some new JavaScript syntax here from ES6. If you're not familiar with that, don't worry too much about it. All I'm doing here is creating a new object. It has all the old state values on it with just this new one updated. The key point is that I'm giving it a new object. I'm not modifying the object that came in. So it is an immutable update. And for actions that I'm not concerned about, I just return the old state. And that is the basis of a reducer function. They're very, very simple. But you can probably see that as you get more and more actions in your system, that switch statement is going to get longer. And that becomes a bit of a maintenance nightmare. So how do we deal with that? Well, we deal with it by just understanding that reducers are just functions. So they can call other functions if they want, as long as they are all pure in nature. And that's what we tend to do. We tend to take a bunch of these actions and split them off into a separate reducer. So we deal with a smaller part of your state object, and that just becomes maintainable. It keeps it all really simple. It means you can test it easily. You build up over time a tree of these reducers. And we call the top one the root. In fact, Redux has a function called combine reducers, which can do all this knitting them together for you, which is really nice. The technique that we use to compose these functions is surprisingly called a functional composition. And all it means is that you basically chain functions so that the result of one function becomes the input of the next, and the overall result is what comes out at the other end. So just as an example, if we've got a function called square, which is just going to square whatever number you gave it, and we've got a function called double, which is going to double whatever number you pass into it, we could create a composed function of the two called square double. So we call double first, and on the result of double we call square, and we return that as the result of this function. So if we called square of 3, we'd get 9. If we called double of 3, we'd get 6. And if my maths is correct, if we called square of the double of 3, we'd get 36. Nice and simple. And we just apply that principle when we're building our reducers so that we keep them in this nice tree shape but it also means that each reducer is itself quite simple in nature. How you structure these reducers is, again, up to you. Some people like to have a reducer per sub-object on the big state tree. Some people like to have a reducer which deals with a certain type of behavior. There's no standard. As long as it works for you, as long as you understand it, and as long as it follows the principles that it's a pure function, it's fine. Okay, so we need to give this root reducer, the top level one, to our store. So when we call create store, we can pass in a root reducer. We can also pass in an initial state object if we like. So we may, for example, when we start the app, load the previous state from the server or local storage or something like that, so we can bootstrap our application. Note we only need to pass the root in because through the composition it will go to all the other reducers. So just to summarize at this point, what happens is you create a store, you give it your root reducer, and when you call dispatch on the store with an action, it will call your root reducer, give it the old state, give it the action. That gives you the new state back, and the store keeps a hold of that. So that's how an update to your system happens. It's straightforward in that there's only one way the code can flow. Okay, so we've made a change, our state's updated, the store's now been set with the new state. That's whatever. How do we actually draw that? Well, the store has another method on it called subscribe. You can just pass in a callback. And that subscribe gets called every time the store has a new state on it. It doesn't give you the state, you have to get that yourself. But basically, all we need to do to render is get that new state, and then whatever rendering library we're using, just call render. And that's, in principle, what we do with all the different binding frameworks that exist. It's very rare that you'll write that yourself because if you're using something like React or Angular 2, there's libraries which will do this for you, but do it in a bit more of an efficient way to make sure that you only need to update the bits of UI that actually have changed. But in principle, that's what they're doing. So to bring it back to that initial diagram that I showed you, we've got a change coming into the system which causes an update, which causes a redraw. In Redux terms, that's raising an action, calling your reducers, and then subscribing to the store to get the new state. And it's actually, at this point, it's worth stopping and telling you that I've described about 80% of Redux's API with those 5 functions. Like, there's not a lot to this. And I think that's really nice because it means you don't have to buy into this really heavyweight framework like Angular 1, for example, where it was everything and but the kitchen sink and you had to use it all. So a bit about that store state object. What I found is that as your application gets more complicated, how you structure this store object, this state object, becomes incredibly important to make sure that it's updating in as an efficient manner as possible. Now, the approach that I take with this, and the approach that many others take with it, is to think of this big object as like a database. Sub-objects on it correspond to like tables in a database. So you could see this as like a table of authors, for example. And just like entries in a database, they have IDs, like a unique ID. So my authors sub-object here is a map. It's a map of ID to an object. So here's our ID. And likewise, if we then need to reference another object in our state somewhere, we don't have to have a copy of it. We can just reference it by ID, just like a foreign key in a database. And if we ever need to indicate order in some way, we can just use an array to do this. Note I'm not doing anything complicated here. It's just a standard JavaScript object. But what I've effectively done is gone through the same database normalization process that you would do when you're designing a database. The benefits that you get from this in Redux is that it keeps your reducers nice and simple. You don't have to have lots of nested ones. You can keep as many at the top level as you want. It keeps a nice flat structure. And that also stops unexpected updates as well. Because we're returning a new object every time we update the state, there's a risk that your UI framework might render more than it actually needs to. Like if we've got a sub-object and we change another sub-object on that and a property on that. If we change that property, we don't want to have to render every single sub-object that it's contained by. We only want to render the bare minimum. So flattening that out minimizes the risk of doing so, and it also means that you've got less work to do when you actually come to rendering stuff. What I've shown you so far is effectively the essence of this library. It's incredibly simple in my opinion. But you may have caught me out on something because I've been talking a lot about how you can only do pure functions. But I also said that everything's really complicated and we've got all these different concerns to deal with, like network requests and logging. And Redux doesn't do any of that because you can't do any impure stuff. You haven't caught me out. It does give you something that you can use to do the more interesting stuff. Anybody who does a lot of server work will be familiar with middleware. It's basically a chain of functions that gets called when your request comes in, but before you have a handler to deal with it, and it lets you do a lot of other stuff. In Redux land, this chain of functions, this middleware layer, is called when you dispatch an action, but before the store gives it to your reducers. So what it does first is it gives the action to the first middleware in the chain, and that can optionally pass it to the second one, optionally pass it to the third, and then it gets passed to your reducers. This lets you do some extra stuff like logging, so you can log any state change that comes into your system. You can do asynchronous actions like make network requests. I'll show you that. Or you can do stuff like crash reporting. So you have the snapshot of the state, you have the actions that come in, you can just send that off to the server as diagnostic info. What you use the middleware for is entirely up to you. You could have a middleware which, for example, checks that you're authenticated before processing a request. So the way we create the middleware is with another Redux function. We've now covered about 95% of the Redux API, called apply middleware. The order is important here. You just pass in your middleware functions in the order you want them executed. And there's an extra parameter on create store to give it the middleware chain. So if we're building a Redux application, how do we handle side effects? How do we make network requests? If a user clicks a button saying, load me some tweets, how do we do that? What we're going to do is we're going to dispatch something that's not an action, it just represents that we want to do something like that. And we'll have one of our middleware things perform the network request for us. There's another functional programming term called a thunk that's helpful here. And all that is just a function. Because if you've got an expression like x plus y, that's going to be evaluated immediately. If it's in a function, it's going to be evaluated when the function's called. So you've delayed the evaluation of that. So, okay, this is my other big code slide. The way this works is we've got a top-level function here, that's our action creator. So remember, they return a JavaScript object that describes what change we want. Well, this one's not. It's going to return a function instead. That function gets the dispatch function, and it gets the get state. So you can read state if you need to do anything complicated. But it allows us to do something more interesting. So we could, for example, this is going to perform a network request. The first thing we could do is dispatch an action to say, hey, we're going to load this item. And our reducer could then do something like set an isLoading property, and then our UI could show a loading spinner. What we're then going to do is make the network request, and when that result comes back, we dispatch another action to say, hey, the item's back, here it is. Now, this is all done in the middleware layer. This is done before any code hits your reducers. Those actions, when they get dispatched, will go through the reducer stuff. By that point, all the impure work has been done. It's finished. We can just update ourselves in a pure manner. Sometimes code doesn't help me visualize things, so I like boxes and arrows and diagrams, so let's just run through this again. So in the normal case, you've got an action creator, and it returns an action, which is just a JavaScript object. If we dispatch that and we've got our Thunk middleware, it'll get passed to that first. What the Thunk middleware is going to do is it's going to say, what you've passed me a function? In this case, it's not. It's just an object. So it passes it through. It'll go to the reducers, and our state will be updated. Nice and simple. If our action creator dispatched a Thunk, it dispatched that function, okay, that's going to get passed to the middleware layer. The Thunk middleware will say, right, this is a function. I'm going to call this function. And remember, the first thing it did was dispatched a loading action. So that goes all the way through the middleware again, and because it's just a JavaScript object, it's going to go through to the reducers. The Thunk, the next thing it did was make that API request. So it's done that. We get a result back, which is, in our case, we were going to raise another action. That action gets put all the way through the middleware layer. Because it's a JavaScript object, the Thunk middleware doesn't need to do anything with it. It gets passed through. At this point, we're finished with the Thunk, and the Thunk middleware says, well, I don't need to pass this to the next person because it's done. So it just drops it, disappears. So with Redux, I've said that it has these principles, and I've called them constraints. And it does this for a reason. Basically, Redux itself was somebody realizing that if they take this unidirectional pattern and they make these set of constraints, you can get some incredible productivity benefits at development time. Because basically, if you've got a list of all these actions that came into your system, what you have is an audit trail of every state change that your application has gone through. That's incredibly important for testers, for example, who have recreated a bug. They have the set of recreation conditions there. They can just send that to a developer and say, start the app up, apply these actions with these values, and hey presto, here's the bug. But because the thing that stores our state, the store, is different and separate from the thing that updates our state, our reducer tree, it means that we can hot swap the reducers without changing the state. So I'm going to jump out into a demo at this point. Has that worked? That has worked. Okay. I have a really, really simple application here. All it's doing is it's got a counter. So one on the left will -1, one on the right will +1. Okay, let's get started. So if I do that, oh, it's gone to 7. Well, that's not 5 + 1. What I've done here is Redux comes packaged, well, it has a set of separate libraries that will allow you to package it with development tools built into it. And one of these, for example, is a log down the side, which will show you all the actions that have come into your system. So you can use it to see what our initial state was. Here it's just a count property of number 5. You can see that an increment action came in, and now our count is 7, so we can see how our state has changed over time. Okay, now I'm using Webpack to build this. Webpack has the ability to swap out code when you changed it and reload it in. So here's my reducer function. As you can see, I have an initial state object where I'm setting a value to 5. Here's my reducer. When I get the increment function, okay, I can see what's wrong here. I've got a count and I'm adding 2 to it. I've just pressed the wrong button there. So Webpack is currently, listening for changes to this file. And when it detects a change, it's going to reload all of those reducers in the application. I don't need to do a browser refresh in order to do this, which is pretty sweet. So if I change this, you see that it's basically, because it's keeping an audit trail of all these actions that have happened in my app and what the initial state was, when I replace my reducers with the new ones, with the updated, with the bug fix in, it can replay all of these actions. So now I can see that the bug is fixed. And I find that incredibly useful because it's like TDD. You're getting incredibly fast feedback when you're developing. The DevTools also have some really nice features in. So if I press decrement a few times and increment, you can see how the state changes. I can undo an action just by clicking on it. And it will dynamically recalculate the state by replaying all the actions again. So with the hot reloading built into Webpack, we can do effectively debugging by traveling through time. We can take our application state at the start, and we can see it evolve as we make changes to the application. If we find a bug, we can fix it. and it will just replay our state, and we can look and we can see that it's fixed. And when I do development, I've got a larger application that I'm working on. I find this really, really handy, especially as your state grows. The Redux dev tools themselves are completely pluggable. So there's lots of different tools that you can use. One, for example, gives you a slider. So you can just slide left and right and see all the state changes get applied. And you basically get snapshots of what it looks like over time. One of them gives you a graph. And the graph will show you how the state object itself is mutating with every action that comes in. You can use as many or as few of these as you like, but it is an option that is available to you. Okay, so if I just restart the slides where I was. So I guess let's cover pretty much the extra 5% of Redux's API. The store has a function called replace reducer, and you give it your new set of reducers, and that's how this achieves that pretty amazing piece of productivity gains. I want to try and sum things up for you now. Because Redux, it's so small that it's matured very quickly, it's stable, the developers behind it consider it pretty much done. So you don't really have to worry about the entire world changing underneath you if you're going to start writing applications in Redux. But there are still innovations in the area, but they're going to come from helper libraries that you can choose to use or not use. So I've got a few listed here that I really like. Redux form. If you've got a quite complicated web form in your application and you want to store that in your Redux state, you end up creating like millions of actions because this form value's changed and this checkbox is being checked or unchecked. Redux form kind of uses a lot of generic actions and does it all for you. So it's really, really nice. Some people don't like it, but I find it's just nice and easy. Redux Saga. You can use this instead of Redux Thunk for your network requests, but it's for people who are really into functional programming. It lets you do a lot more complicated workflows. Let's say, for example, if you had to make an API request to get a list of items, and then you had to make an API request for each item in that list to get its values. Redux Saga is, in my opinion, a bit better for that because you can express how certain asynchronous actions relate to other asynchronous actions. Other people just prefer to do it with Thunks. It's up to you. Reselect is a really useful library. So because you've got quite a complicated state object and it's incredibly normalized like a database, you end up writing a set of functions to take an ID and look it up from another piece of the state, just like you're writing SQL queries. Reselect makes these really, really efficient. So it'll remember a value that's been calculated from your state, and if it needs to be recalculated, it'll do it. And if it doesn't need to be recalculated, it'll just give you the old one without looking it up. Redux Observable is for anybody who's interested in RX. Netflix built this, and it basically lets you write RX functions, and the result of an RX function causes an action to go into your dispatcher. So basically, you can kind of write these helper libraries to plug Redux into whatever you're already using. But you don't have to if you don't have those problems. Now, the JavaScript community moves along very, very quickly, and it seems like sometimes when you start working on a project in a particular framework, it's already been outdated. Some people say it's a problem, but really, I just think it's because JavaScript is a bit of a hotbed of innovation. However, the concepts that we've talked about, the ability to debug with time, replaying your state, the idea of having updates be pure and immutable, the idea that because your actions are just JavaScript objects, because your state is just a JavaScript object, serializing it to local storage of the network is really simple. All of these concepts, I think, are going to be around for a long time. I think any new JavaScript framework that comes out that tries to compete with Redux that doesn't have time travel debugging is at a loss already. People are going to start demanding this stuff. So even if Redux falls out of fashion, because it's such a small library, and because I think these concepts are incredibly useful, I think it's worth spending a bit of time to learn. And the creator, Dan, has two 30-minute videos which basically build Redux from scratch out of code and explain everything that I've talked about. However, I do want to mention some of the alternatives just to wrap up. Elm is a functional programming language for the web. You compile it. It basically inspired Redux because it has this update pattern that Redux has, but it's baked into Elm. It also allows it to do some really nice things, like you don't have to have a Thunk middleware to do network stuff. That is provided by the Elm runtime for you. There are other state management libraries in the JavaScript world which do the same thing but are more of a functional reactive style, like MobX and Cycle.js, if you're interested in any of those. And I think really out there is Relay and GraphQL, and this is where your UI components, rather than getting the state from something that holds it, they ask and say, I'm interested in these particular properties from the state object. And the Relay GraphQL runtime will turn this into a database query and get that from your store for you. So it's along the same lines, but it's more transactional in nature. So I think these kind of technologies is where we're going after Redux. Okay, and with that, I think I have about 10 minutes for questions.
Thank you, sir. So, who would like to start off the questions? We'll go there and then to the end of the row next.
Hey, I'm just curious, how would you handle hydrating the state when the app first loads? So let's say, for example, you've got stuff in local storage, or maybe you've got something on the server that you need to pull in to the application as it's loading and before it started. How do you handle that? Yeah, so in the application I'm creating at the minute, which is just a character creation system for 5th edition of Dungeons and Dragons, because creating characters is a bit difficult. I've got a lot of data that gets saved, so the idea is you'll do a session of the game, you come back next week and you'd want everything loaded up. So I just basically have a bootstrap function that does that. Kind of, it can make a jQuery network request if necessary, or you can just read from local storage. So by that time, when you get the answer back, it's at that point you create the Redux store and give it the initial state. The other thing you can do is you can just initialize the Redux store and have your initial state be so that everything's loading. Dispatch another action immediately to say I'm going to go and get the data from the network. And then when it comes back, at that point you hydrate. So really it just depends on how much state you're wanting to persist.
Hi. If I'm understanding this correctly, every time you apply a reducer, you are essentially making a new copy of your state.
That's right.
If you've got a very large state, you're creating multiple new copies. Is there any performance or memory implications in that? Or I don't know enough about Java's memory management to know if that's handled efficiently.
A lot of the performance problems I found are on the rendering side of that. So there's libraries like Immutable.js which can use a few tricks to mean that you're not creating lots of intermediate objects as you craft your larger state object, which we use quite heavily. But I found the performance issues are on the UI side and about how you structure your reducers to avoid the intermediate state objects being set. So for us, for example, we like to keep our reducers as flat as possible, but we also then use stuff like reselect so that we're not constantly querying the state. We only need to query it when something actually changes. And with React, so React, for example, is really, really good when you're having immutable objects, because what React will do is it will only render to the actual DOM the very small parts of your DOM that have changed. And you can use kind of helper methods in React, like should component update, to do some very quick checks to say, this object hasn't changed, I don't need to render. So because objects are immutable, it means you can compare them by reference. So all you're doing is a very quick pointer check, effectively, to see if an object has changed. You don't have to do the deep comparison. So those are the optimizations that I found, and I've got the application I'm working on. We can stream prices incredibly quickly and not really struggle with this.
So does that mean that reselect is almost a mandatory addition to get over the problem of state storage?
I probably say yes, but you can get most of the way yourself just by writing functions. If you need to have its efficiencies like memoizing state, it's useful. But I think as your application grows and you end up creating this incredibly flat state structure, you end up writing functions to grab bits of state, helper functions to look up an article by ID. So you kind of build this interface over your state yourself. And all Reselect is doing is making that efficient.
Okay, down in the front, and then we'll come up to the back.
In your example, you had the thunks for asynchronous actions. And in your example, you had one that did a slow network request. So initially, it dispatched an action to set a loading state, like spinner or whatever in the UI. And then when it finished, it would clear that spinner, say, again, by another action.
Yeah.
I'm guessing you can have two of these thunks running in parallel. And so in that example, if a user issued two slow-running things, you could end up with the problem of the first one clearing the spinner when actually you really wanted to still show that because the second one's still running.
Yeah. So there's ways of doing that. So you could have maybe an ID on your action to say this relates to a particular network request. So we've got we have a similar concern. So we can look up requests to get, for example, the current spot date for a given FX currency pair. And if the user is very quick and changes currency pair before that was resolved, we may end up setting the wrong date into the UI, and it may mean that the user is trying to trade on a date that isn't applicable for that currency, which is pretty catastrophic. So we do stuff like keeping track of what network requests we're sending so that we can reconcile it when answers come back. Again, how you do that is entirely up to you. Redux doesn't give you anything to do that. It's just simply about updating the state in a predictable way when an action comes in. So Redux Saga is potentially useful there as well if you've got lots of network requests that you need to chain, but it really depends on the problem you're trying to solve.
Okay, we had a question up at the back, the gentleman in blue.
Hi. If you've got all of your state in one object and you've effectively got one reducer function, one root reducer function, how does that work with encapsulating the behavior and the state for a reusable component?
Yeah, so I think one of the weaknesses of Redux is that reusability of UI components is very tricky with it. And Elm, like I was saying, Elm kind of inspired Redux, and Elm handles that a bit better by giving each action an ID so that it knows which particular UI component it's talking about. Dan Abramov, the guy who made Redux, recently posted an article saying you might not need Redux. And one of the arguments that he made in that was that actually you don't need to store all of your state in this global state object. Because that is a global state object, any state that needs to be stored globally is good to be stored there. But if you've got some UI state that is maybe only relevant in one little React component, it's perfectly fine to store it there. It just depends, really. But I think, in general, the reusability of controls is a big area of concern for me with Redux. And you have to do stuff. There's actually another library called Redux Elm, which gives you the kind of ID stuff if you need to solve that problem. So it is solvable.
Had a question down on the front row here.
Yeah, just a quick one. So that time travel debugging is really amazing, but does it work when you use middleware? Because then you're not dealing with any pure functions anymore. Yeah,
it can get a bit tricky when you're doing middleware. So if you've got a network request, obviously, if it has to remake that or something like that, it can, you get the unpredictability. But if you're rapidly developing like a new UI component, you can really quickly see how it responds to a certain change.
Okay, thank you.
Time for one more question, if we have one. No? Excellent. Satisfied all of the queries.
Well, I will be around for the rest of the day and at the after party, so if you want to grab me for anything, please do.
Excellent. Just before we disperse, to let you know, the next session starts very, very quickly, so we don't have coffee breaks or time for queuing anywhere. If you need the loo, go now. But the next sessions in Waterside 3, we have designing, developing and running IoT solutions at scale. Cinema 1, just along the corridor, delightful UX for distribution systems. And here in Cinema 3, data explosion, energy restrictions, security and optics with Suzanne Klein. Would remind you again, if you're interested in the workshops, the next workshop in Cinema 2 is Kubernetes, I believe that's how it's pronounced, but I may be wrong, with Matt Bates. If you're interested in that, pop along there now. Otherwise, just before you leave the room, if you join me in saying thank you to Sam in the usual way.